Alright, so this is the end product we're going to build today. We have like a little home page. Click on load map, and we'll have our map centered at Sheridan College to start off with. We'll enter a location. For example, we may want to go to CN Tower, Toronto. And we hit let's go. And it'll center at CN Tower, and it'll give us a route to get to CN Tower from Sheridan in Brampton. And it'll have a list of different steps down here for where we'll have to navigate to. So that's the idea. That's our end goal for today. So first thing to do, create a new project. So file, new project, and we come to single view application. We'll hit next, and we'll call this map project. And we're going to use Swift for the language. And we'll give it a home. All right, so I'm going to organize my files into separate groups this time around. So I have a little new group for view controllers. Storyboards. And classes. We'll just move app delegate into classes, view controller into view controllers, and the storyboards into the storyboards. Okay, so we'll start off with the UI itself and deal with launch screen.storyboard and main.storyboard. We'll just put a small little loading message on launch screen. So look for a label. Right, so that'll be our launch screen. And we'll focus our attention on main storyboard. So main storyboard, we'll have our home page. And I'll put a little title like My Maps. With a little button to begin. And we're going to add a second page to this application. So better off adding the second page's view controller in first. Then we can do it all at once. So I'm going to right click on view controllers, the folder. Let's say new file. iOS Cocoa Touch class. And subclass of UI view controller, and call this map view controller with languages Swift. And give it a home. All right. So Now that we have the map view controller, we'll do the work for map view controller afterwards. Let's start by dragging our view controller over and populating it. So first thing I'll do is I'll subclass the view controller, so highlighting the yellow circle, making sure my third option is highlighted for identity inspector, and choosing the class to be map view controller. And then we'll put a navigation bar at the top. And the title for that will be My Map. And we'll add a couple of bar button items. One for our back button. And one will be for executing our map calculation. I'll just say, let's go. And you might as well connect the Let's Begin button from the first page to this page. So Control, drag, and choose Present Modally. So we're going to add three things to this page. First is a text field. So I'll put that at the top. And the placeholder text will be, where do you want to go? And center it. And the thing below it will be the map view. So I'm going to search for a map. So it's the Mapkit view. We put it right below. Stretch it to halfway down the screen. And then the last will be a table view. So just a small little table view. And that'll be our page. All right, so before we can run this, let's go to project settings and bring in a couple of libraries and frameworks. So first thing we're going to do is go to link frameworks and libraries. And we're going to bring in core location. So we want the core location framework. And we want to bring in the Mapkit framework. We'll hit add. And so those are the two frameworks we're going to bring in for this project. Now in terms of location awareness, if we want to actually enable location awareness and let it find where we are, we're going to info plist, and we'll add an extra setting to info.plist. It's a privacy setting. So let's hit plus. And we'll say privacy. And we're looking for location when in use. In use description. Now this purpose of this is just to provide the message that you want to see in the alert box that'll pop up when the user is asked, do you want to provide your location? So we'll just say, please allow us to use your location. Okay. So now we'll move into Map View Controller, and we'll start writing some code. First thing we'll do in Map View Controller is bring in core location, and then we'll bring in Mapkit. Next, we'll declare some delegates that we want to bring in. So we're going to extend UI View Controller. We'll extend UI Text Field Delegate. And then we'll extend MK Map View Delegate. We'll bring in the table stuff after, so we'll do tables last. So the variables we're going to bring in, first off, is we need location manager. So we're going to say let location manager equal CL location manager. And then we're going to create a location object to center around Sheridan's Davis campus. So we'll say let initial location equal CL location. And we'll hard code it to the lat long for Sheridan. And I already looked this up on latlong.net, so it's 43.655787, and longitude is negative 79.739534. And then we're going to declare a few IB outlets. So we'll say IB outlet var my map view extends mk map view with exclamation mark. The next one, IB outlet var tb lock entered extends the UI text field exclamation mark. And the third one, we'll declare for the table, which we've never really done before. Var, and then my table view extends UI table view. So in the past, we've never really brought in the table view variable. And so this is our first time doing so. The reason we're doing so is because we want to refresh the table. That's the only reason we're doing it. Otherwise, in the past, we've never had any reason to declare a table view and to use it. Now, another thing I'm going to declare is an array, but it'll be an array of 1. It's going to be an array that'll host all of our steps for when we do a root calculation. So I'll say var root steps is equal to, and I'm just going to populate it with one item. Enter a destination to see the steps. And that's it. So it'll be an array of 1. We'll default our table to just show that array of 1. And that way, at least the table has something in it, so it doesn't look empty and awkward. Now we should get a little bit of housekeeping out of the way, so the text field should return method that we need to clear our keyboard, let's get that done. So func text field should return. and we'll just return text field dot resign first responder. All right. So what we're going to do is we're going to create that method to center our map on a particular location. So we're going to create a method right here. So we'll say func center map on location. And we'll pass in location being of type CL location. But before I want to declare a constant just above it. So we're going to say let region radius extend CL location distance and set it equal to just 1,000 units. Now, what we're going to do with this CL location distance or region radius variable is we're going to allow our map to zoom in on the location, but zoom in such a way that the area visible on the map is basically within that value of 1,000 units each direction. In fact, I'm actually going to double it to 2,000 units when we actually create our stuff. So we'll say let coordinate region equal mk coordinate. This is a long one. Mk coordinate region make with distance. And so the arguments passed in is first our lat long. So we're going to pass in our coordinate that is, location.coordinate. That is passed into the method. The second thing is the range latitude-wise. So I'm going to say region radius. I'm going to double it, so I'll times it by 2.0. Do the same for longitude, so region radius times 2. Just to show a better view. And I'm going to tell my map to center on that area. So I'm going to say my map view dot set region to coordinate region and animate it. So I'm going to say true. Let's let it zoom. All right. So now we can actually start loading a place into Viewdidload. So in Viewdidload, first thing we'll do is we'll call that method center map on location, passing in initial location. Then we'll create our drop pin. So we'll say let drop pin equal mk point annotation. Set the coordinate for the drop pin. So drop pin dot coordinate is equal to initial location dot coordinate. Add a little title to it. So drop pin dot title. We'll say starting at Sheridan College. And then we're going to add this pin to our map view. So we're going to say my map view, so self.myMapView.add annotation. And we're going to add the drop pin. Finally, we'll tell the map view to select this annotation, meaning center on it, and also enable the text bubble. So self.myMapView.select annotation to drop pin, and say true for animated. And so now let's connect everything up and run this thing. So switch back to main storyboard. And highlight my yellow circle for view controller and enable my connections inspector. So my map view. And I won't do the table view stuff yet. We're going to leave it till last. But I'll connect the TB location entered. Then click on the text view, connect the delegate to the yellow circle, and connect the map view, its delegate, to the yellow circle. And let's run this. And there we go. We're centered on Sheridan College. So we're going to create an event handler that'll find our new location. So we're going to tie it into the Let's Go button. So I'm going to move over to, so I'll stop running this, and I'll move over to back to mapViewControl.swift. And below Viewdidload, I'm going to create an IB action. Call it, well, call it find new location with no arguments passed in. All right, so first thing we're going to do is when we click the Let's Go button, so somebody's entered some search term like CN Tower Toronto, we click Let's Go, and first thing we want to do is retrieve the text. So we're going to say let loc entered text equal, and then tb loc entered dot text. All right, so we got the text there. Now we're going to use an object called a geocoder, or CL geocoder, to convert that text into a lat long that we can work with. So we're going to say let geocoder equal CL geocoder. Now there's one method call we're going to make, and that is to convert that that string into some sort of lat long address that we can work with. So we're going to write geocoder dot geocode address string. There's a few of these, but we just need the first one. And it has a completion handler. So we're going to do a little bit of block coding here. So the first thing is address string will just be our loc entered text with an exclamation mark. And our completion handler, I'm going to blank that out. I'm going to let the round bracket autocomplete. I'm just going to hit enter there to make some space. So this closing round bracket will match up with my method call, because we're going to put some block code in. Now if you recall from Objective-C, we use a character like this, just above the number 6, to represent block code. And just to recap, so block code is code that you can embed inside a method call. So we're going to embed it inside a method call here. Right? That's the aim, because we want to be able to have some code execute upon completing this method call. So in Swift, we don't use this keyword or this key letter. Instead, we go straight into using a set of curly brackets. So I'm going to open up a curly bracket. I'm going to put the closing curly down here just above my round bracket to match it up so I don't forget. And then on the other side of the curly, first thing I'll do is I'll declare any arguments that will be passed in. Now you have to worry about these arguments are already predefined. You should already be using them right away anyway, because that's what the method call expects. So there's 2 arguments, and they go inside round brackets. The first one's called place marks, and the second one is error. So for any error handling. The next step is there a return type for this embedded piece of code? So we're going to use that arrow just like in typical method calls, but we're going to say void because there's no return. So it's not going to return anything. All the data will be placed inside place marks and error. And then we'll write the word in. So in signifies the beginning of my code that goes inside this embedded set of method call. So first thing I'm going to do is just check if there was an error. So I'm going to say if error does not equal nil, then we'll do like a little print. I'm not going to get into putting in an alert box for time reasons. So, but you would typically at this point put in an alert box and just print out your alert message there. For now, I'm just going to do a little print, which is just like your NSLog, just for our debugging purposes. So we'll say error and then comma error. So whatever error was printed out. All right. Otherwise, we can just jump right into doing our geocoding work. So when we search for something, it's going to return a set of results, not just one. So if I search for CN Tower on its own, it will return back a bunch of CN Towers all over the world. And when I say CN Tower Toronto, it returns back one, but it's still going to return a set of items. And so what we want to do is we want to be able to catch those items, and they're called place marks. So just for simplicity, I'm just going to retrieve the first result that comes back as opposed to a set of results. Now, you could take this example a step further and use that table that's in our view to list out all those options. Maybe have an event handler, so you click on a particular item and then let it recenter on that as your result. So that's another option, but we won't get into that today. So first thing I'm going to do is I'm going to retrieve just the first item. So I'll say if let place mark equal place marks dot first. Then the first thing I'm going to do within here is retrieve the coordinate, the lat long of that place mark. So I'm going to say let coordinates extending CL location coordinate 2D equal to place mark dot location with exclamation mark dot coordinate. Now we're going to convert this into a CL location. So we're going to say let new location equal CL location, passing in the latitude and longitude. So latitude will be coordinates dot latitude and coordinates dot longitude. And then we'll call our center map on location, so self.center map on location, passing in new location. So the map will center on whatever we search for initially. And we'll throw a drop pin on that new location. So we'll say let drop pin equal mk point annotation drop pin dot coordinate equal to coordinates. We'll say drop pin dot title equal to placemark dot name. We could just take the text that was entered, but it's more accurate to use placemark dot name. And then add it to our map. So self dot my map view dot add annotation, adding in the drop pin. And finally self dot my map view dot select annotation, passing in drop pin, animated will be true. And this should be enough for us to run to test out finding that new location. All right, so let's run this. Well, we can't run this until we connect this first. So going back to my storyboard, highlighting my yellow circle, and I have my find new location event handler, connect that to let's go. We have enough to run now. All right, so let's begin. All right, so I'm going to type in CN Tower Toronto. Hit let's go. And it centers on CN Tower. In fact, you can even type in Square 1 Mississauga. And it redirects there. You can try, let's be adventurous and try Olympic Stadium. Montreal. And there it is. And so you can drag it around. So that's the first part. So initially what we're trying to do is just get the map to work and get our little search bar, a little pin annotation up and running for every place we search for. The next step now is to do route calculations and to actually draw a route from where we are at Sheridan to where we want to go and list out our steps below. All right, so continuing on to get our route calculation going, we need to bring in an object called mkDirectionsRequest. So we're going to continue on after the annotation. So I'm going to say let request equal mkDirectionsRequest. Right? And we're going to what this directions request object requires is what's our starting point, what's our end point. So those are the two main things it requires. And then there's a couple other settings we'll enable as well at the same time. So we'll say request.source is equal to mkMapItem, and its placemark argument will actually require us to convert our initial location from a coordinate into a placemark object. So it actually wants the placemark object instead. So we're going to say mkPlacemark, passing in a coordinate and we'll pass in initial location dot coordinate, and our address dictionary will be nil. That sort of narrows us down to specific dictionary of addresses, but we're not going to do that. We're going to do the same thing for our destination. So we're going to say request.destination is equal to mk map item place mark, and we'll do another mk place mark, passing in coordinate being our coordinates. Address dictionary is nil. So the coordinates that we have from up here, it's already in place mark format. So I don't need to do any conversion. I can just plunk it right into mk map item. So I have my source and my destination. It's asking me to do some unwrapping. So let's do self.initialLocation.coordinate just to make it happy. Now a couple of settings we'll add in for this directions request. We'll say, do you want alternate routes or just the one route, the best route? So we'll say no. You could, if you want to grow this project, you could say yes to it or true to it, and let the user in the table view choose which route to take. Right? But we're not going to go that far today. But we'll say request alternate routes. I'm going to say false. Right? And transportation type request transport type is equal to automobile. Right? So just by car. So that means if you're requesting a route halfway across the world, then this might crash. So now we have our directions request object. What we're going to do is we're going to create a directions object that will actually calculate the directions. So we'll say let directions equal mk directions, passing in our request, which is above, so request that we just defined. So this request object has our source, destination, and any other preamble data we need. Now the next method call, this one's going to allow us to do the actual calculation. And it has some block coding with it as well. So we'll say directions.calculate. And just throw in our completion handler. All right, so I'm gonna add some extra space here, like I did before with the last completion handler, and like I said before, we're gonna start off with some curly brackets, and we'll say unowned self response error in, and then we'll start our coding. So what we want to do here is, at this point with calculate, is that we have what it will do a calculation for steps. It'll give us a step-by-step list of ways to instructions to take to get to our destination. So we need to convert that into something where we can draw on the map. So something called an overlay, which we'll talk about in a second, and also something to populate our route steps array with a list so we can put it into our table. So there's two things that are going on here. Right? So we're going to use a for in loop to do this calculation. So we're going to say for route in response dot routes exclamation mark, open our curly. I'm going to close my curly down here. And then we'll fill it in. I should close off my closing curly. There, just get rid of that error. There, so everything's clean so far. All right, So I'm going to say self.myMapView.add. We're going to add something called a polyline. So every line that we add onto a map, whether it be a bounding box or it be a route from start to destination, any line we draw is called a polyline. So we're going to add a polyline. So we're going to say route.polyline. And we'll add a level to it, being mk overlay level dot above roads. So it's either above the labels or above the roads. We'll specify above the roads. And we'll set it to be visible. So self.myMapView.setVisibleMapRect. We're passing in our route.polyline.boundingMapRect. And we'll say animated true, just to give it a little flair. Now, we're going to populate our array. So we're going to say self.rootSteps.removeAllObjects. Let's remove all. And we'll do another for in. So for step in root.steps. We will say self.rootSteps.add for step.instructions. At this point, it's not enough to run this because it will not draw the lines that we're looking for. It'll recenter the map and it'll populate both pins, but you won't see the lines. Even though above here we say add polylines and set our visible map rect, but it's not enough. We actually have to configure the polylines itself. So there's a method we have to bring in from the delegate, and we'll do it right below here. So I'll do a little bit of cleanup because a ton of brackets here that are just sitting. So we'll clean that up and then I'll bring in that method. Right. So outside of the method call, outside of the event handler, just down here, we're going to call in a new method from MapView. So I'll say renderer for, and it'll say MapView renderer for. There we go. You type in renderer for, it'll auto-generate this method stub that we need. And this allows us to configure what each line is going to look like. So like what color, how thick is the color, really simple. So we're going to say let renderer equal mkPolyline renderer, passing in our polyline overlay, which was passed in as mkPolyline. So let's just correct that. It auto-completed to polygon instead of polyline. There. So mkPolyline renderer. So the difference between polyline and polygon is that polyline, as you might guess, is just for lines. Polygon is for shapes. So we'll say renderer dot stroke color equals UI color dot blue. And then renderer dot line width equals, let's say 3.0. And it'll return renderer. And that'll be our method. And let's just fix that. So just a little carryover from the incorrect auto completion. So yeah, so this method will now allow us to draw polylines on the screen. And so now you can go ahead and run it and type in a destination like CN Tower Toronto and see lines pop up. Okay, let's begin. Type in CN Tower Toronto. CN Tower, and there's our route right there. All right, so last step is to get the table going. So we put in a line of code earlier. I took it out because it was causing a crash, but we're going to put it back in now, and that is to refresh the table, but we haven't really configured the table. So we're going to put it back in. So self.myTableView.reload data. Right, this will refresh the table. Now we're going to go ahead and populate the table and make sure that it actually can run with the information that we're looking for. So at the bottom, maybe somewhere around here, I'll put my table methods in. And we're going to keep it really simple, really generic. We're not going to get into creating some fancy cells and stuff like that for this exercise. So we'll take 3 of the 4 required methods for getting a table working. We'll start with number of rows in section. Before we can do that, we need to bring in our 2 delegates for the table, which we didn't bring in before. So I'm going to scroll back up to the top. And we'll say comma UI table view data source and UI table view delegate. So we have to bring those in so we can actually bring in the table methods that we need. Then we'll just take in those steps. So the first one being number of rows in section, or just how many rows we're going to have in our table. Second one is how thick is each table cell going to be. And the third one will be what does each table cell look like. So UI table view data source and delegate. And now it's complaining for the table methods. So I'm going to go back to the bottom where I had some space allocated. Now I'm going to type in number of rows in section. And here I'll just return root steps.count. So how many steps there are in the table, or sorry, in the array of root steps. The next one will be how thick is each cell going to be, so height for row at index path. So height for row at, I'm going to hard code it to 30 pixels this time. So return 30, because it's just one line of text. And then the third one will be what does each table cell look like. So we'll say cell for row at, and here we're going to use a generic table cell. So we'll keep it really, really simple and small. In the last exercise we did, we used a custom cell, so the code looked a little complex, but this time we're going to keep it really simple. So we're going to combine the scenario of DQ reusable cell with is it instantiating brand new cells into a smaller line of code. So we're going to say let table cell equal table view dot DQ reusable cell identifier. Keep the identifier as just the word cell. And we'll really simplify it down, saying that if this is nil, then instantiate a UI table view cell. There. So that's much shorter than using our custom cell code from last time. Now we can just add the text. So we'll say table cell dot text label question mark dot text equals root steps index path dot row as string. And then finally return table cell. And this is probably the shortest self-road index path we've written to date. And let's see what the warning says. Yeah, so it's saying string to string casting always succeeds, so you could actually take that out. All right, so last thing we're going to do is connect everything up, run it, and we should have a table up and running. So now, switching back to my storyboard, highlight my yellow circle, going to my connections inspector. Now we can connect up my table view and connect up data source and delegate to the view controller, or the yellow circle. And now we can run it again. We see our full instructions at the bottom of the list. All right, so let's begin. You see now we have enter destination to see the steps, so the original array value. And now we'll type in Olympic Stadium Montreal. Okay, let's go. So it plots a long route from Brampton to Montreal, gives us all these instructions down here. And so what did we cover in this project? Well, we covered essentially how to play with Mapkit, how to get directions, how to do directions requests, how to handle block coding or embedding code within method calls, dealing with drop pins, and essentially this allowed us to build an entire Google Maps or directions type application of our own, well, with using Apple Maps.